Hello everyone, I hope you all are doing well. Recently, PV solar system installation gained strong momentum in Lebanon. And been talking to a few of my colleagues in this field, they raised few concerns regarding the approach and the things are considered during the design of the photovoltaic and the advice that designers are providing to their system, to their client. This presentation will discuss the PV solar system for residential and commercial. We're only going to discuss a few points, things to consider during your design. So during today's topic, we will include electric PV generation for Lebanon. We will talk briefly about the importance of photovoltaic system, impact of areas. Are you installing it on the coast? Are you up in Bekaa Valley, up the mountain? Which area? We will give you a conclusion based on solar GIS and a few pictures from the field. Then we go into PV solar system design, tips for design. What should you consider during your design? What's the recommended minimum layout to protect your system? And then we go to a minimum requirements. And then my recommendation. What should you advise your client? How should you approach your client? And then we give a conclusion. Before we start, we need to introduce photovoltaic. Photovoltaic uses the sunlight as a fuel to generate electricity. If you have a diesel generator, you need to bring diesel into the tank of a generator for it to operate. If the diesel gone, the generator will turn off. Same concept. The photovoltaic replaces the diesel fuel with solar photon, solar light. The stronger the light, the stronger the sunlight, the stronger the output power. Of course, every single panel, every single wafer for the panel PV has a maximum limit, has a maximum. We cannot exceed the rated value of your panel, of your system. This is known as photovoltaic technologies. يعني بالعربي الألواح الكهروضوئية بتستعمل أشعة الشمس، تتحول أشعة الشمس أو الطاقة الشمسية، الأشعة أو الطاقة الموجودة بالإشعاعات الشمسية لكهرباء. بالنسبة للديزل جنريتر، بالنسبة لمولدات المازوت، إذا ما في مازوت ما في كهرباء. نفس الشيء بالنسبة للطاقة الشمسية. ما في شمس ما في طاقة. وكل ما كانت أشعة الشمس قوية وعلى الألواح كل ما عطيوك طاقة أكبر وطاقة stable. طيب. So, for me to achieve an optimum output, I need to have solar light. I need to have a solar light connected or directed to your panels at an optimum degree to achieve the optimum output. So, the most important element in my system is the solar radiation that reaches your solar cell. The most important element is the solar radiation. هي أشعة الشمس that reaches the panel cells, which determine your power output. In Lebanon, this is based on a solar GIS. In Lebanon, not all Lebanon has the same solar density, solar radiation density. From this figure, it shows us that in the Bekaa Valley has higher solar radiation than the coast. For those who travel between the coast and the Bekaa Valley, we have the mountain. بلبنان في السلسلة الغربية والسلسلة الشرقية. السلسلة الغربية very high. عندها علو كتير عن البحر. كل الموجة، كل الضباب والموجة والبولوشن من الساحل حتى تبخر المياه من البحر المتوسط it will be blocked. السلسلة in the western mountain, السلسلة الغربية, it will block it, which means in this area the solar radiation that reaches your panel is less than the solar radiation that reaches your panel up the mountain or in the Bekaa Valley. And that's supported by Solar Atlas and Solar GIS. Look at this one, guys. Pay attention to this. In the same day, up in the Bekaa Valley in this area, Baalbek in the region, you have 7 up to 7.2 kilowatt hour per square meter per day. That's your daily total. While if I go to, let's say, this area, I will have between 5.2 to 5.6 kilowatt hour per square meter from the solar radiation per day. As you can see, I dropped almost 2 kilowatt hour per square meter per day between two areas. It's very critical and very important to notice the following. If I am installing a solar system in the coast and I install the same solar system up in the mountains, they will give me two different output under these conditions. Again, guys, in some days, the sun will be very clear, the sky will be very clear. No disturbance, no cloud, nothing. Of course, they might give you similar output. However, we are talking in general. So as we discussed, there will be a almost 2 kilowatt hour per square meter drop between the two areas. It's very critical and very clear to us that if I install the same system in these two different areas, they will not give us the same electric output energy throughout the year. To say it in Arabic, المعلومات الموجودة بالنسبة لأشعة الشمس. أشعة الشمس أقوى، عندها قدرة أكبر إنها تنتج طاقة أكبر من الطاقة الشمسية، من الطاقة الكهربائية في الجبال، في أعالي الجبال وفي البقاع. الأشعة بتكون أضعف على الساحل اللبناني وفي الجنوب. اللبناني. والمعلومات اللي موجودة من خلال سولا أطلس وسولا جي اي اس بتفرجينا انه عندنا دروب حوالي كل يوم 2 كيلو وات اور بالمتر المربع يوميا. هيدي صورة مأخوذة ب 31 جولاي 2018 الساعة 10 و54 دقيقة. هيدي الصورة مأخوذة من الأرز، من هالنقطة بالجبل فوق، وعم نصوصها بالساحل. هيدي الصورة بتفرجي تحتنا موجود الساحل. هيدي الغيوم والتبخر من البحر خاصة بالصيف بتفرجيك هالغيوم. ايام هالمنطقة بتكون صافية وايام بتكون cloudy like this. In English, guys, this picture is being taken while I'm standing on the western mountain looking at the water, which means I'm standing on this mountain and facing the coast. And you can see the amount of cloud or water evaporation that's been stuck between this mountain that's very high and the coast. So of course, the sunlight that goes down will lose its energy. Part of its energy will be lost because of this cloud, or the pollution, or the water evaporation of the sea. Is that clear why solar system give us way more energy, way more power up the mountain in Bikar Valley over the coast? So this one point that we should consider when we design a solar system. This can cause because of humidity, pollution, etc. Any other reasons? Now, if you refer to a previous slide, and also we go obtain the GIS that give us a photovoltaic power potential. This slide, this map, it gives us an indication of the photovoltaic potential, and you will see that I will have up to almost all around 20% reduction in daily power if I installed 1 kilowatt power solar system. In the Bikar Valley, it can give me 5.4 on average, 5.4 kilowatt hour per day. That's a daily total. In some other areas where there's a green, guys, for those who live in Lebanon, إذا بتطلعوا عصير الدنية وعيصون this area, عطول, you always have خطيطة, you always have a fog that also reduces the amount of solar system. It will be reduced from 5.4 to 3.8, and on the coast on average between 4.2 and 4.6. So this reduction equate almost to 20%. يعني حتى الجي اي اس بتفرجينا انه انا اذا حطيت 1 كيلو وات 1000 وات من الطاقة الشمسية في البقاع او الجبال قادر يعطيني لحد 5.4 كيلو وات اور من الالكتريك انرجي بالنهار، بينما بيصير الضنية بهالمناطق او على الساحل بيعطيني between 3.8 to 4.6. Of course في بعض الأيام بيكون الجو كتير صافي، بيكون very clear sky. Then your system might give you similar output. Okay? So it's very important for us as a designers to advise our client. يعني I have a lot of people come to me and tell me 4 kilowatt or 1 kilowatt or 5 kilowatt solar system لازم يعطيني 5 kilowatt. It's not possible. لأنه ال 5 kilowatt solar panels حتى يعطوك ال 5 kilowatt بدها تكون طلع على الداتا شيت بدها تكون you have to have 25-degree temperature, 1000 watt per square meter sun radiation, 90-degree on your panel. No obstacle, no disturbance. So this 20%, guys, equate for the average along your entire sea coast. على الساحل في خسارة on an average 20% من الطاقة يلي ممكن تنتج في نفس السيستم في البقاع أو في الجبال. Now, to conclude from what we did, a 5 kilowatt PV panel installed in Bekaa Valley, they can produce up to 25 kilowatt hour per day of electric energy. The same 5 kilowatt PV panels are installed in the coast, let us say around Byblos area, in this area, the system can produce up to 21 kilowatt hour per day of electrical energy. This reduction of 16% must be considered. You will see later on in another slide, we will talk about what you should consider when you have an energy storage and daily consumption. This 5 kilowatt, people will consider that 5 kilowatt, that's a 5,000. They divide it by 230, which gives them more than 20 ampere per day. They will think that the sun, I have a sunlight of 10 hours in summer, that means this is going to give me 50 kilowatt hour. No. The energy, the sun go up in the morning shy, gets stronger, and then goes weaker. This is your average. Even the 5 kilowatt PV solar system, it's not possible for you to reach 5 kilowatt as an output. That's why we always add a 20, 30, 40% extra PV panels to make sure your inverter, if it's 5 kilowatt, will work at 5 kilowatt. We add this extra percentage based on the location and our assessment of the area and the system design. In Arabic, guys, إذا نحن شغلنا 5 كيلووات 5000 watt solar system, if you put solar system 5 kilowatt in the Bekaa Valley بالبقاع بيعطونا 25 kilowatt hour per day of electric energy. نفس السيستم, same system بنحطه on the coast على الخط البحري بيعطينا up to 21 kilowatt hour. It's worth noting, guys, it's very important to mention that your chosen equipment, what you choose for your MPPT, it's very critical to maintain maximum power. It's very, very critical. Also, your inverter efficiency. These days, some people use a separate charger controller and then they use an inverter separately. This system has a different efficiency if you go ahead and you use all-in-one system. That you have MPPT and you have your inverter and a UPS and APS, whichever you have in your system. So your chosen equipment efficiency will drop the system down further. Okay, guys, before we commence the design, this lecture is going to take you through a few questions that you need to answer. Question number one, your system, is there a grid or a generator power available? Question number two, do you have the house electric load chart? What do you mean by house electrical load chart? Do you have the consumption throughout the 24 hours? Is the consumption heavy in the morning, midday, or evening? What sort of consumption do you have at night? Is there a need for an energy storage? Because if there's no need for an energy storage, your system has to meet certain criteria for Lebanon. These questions are valid for both commercial and residential projects. After you obtain the answers to the questions, then now we can start the design. If you answer yes, there is a grid. Is there a grid injection requirement? Do you live in an area where you can inject to the grid? You can sell to the grid. Make sure you size your battery. Make sure you size your battery to support your electric load after sunlight period. To size your battery, we already discussed this in a previous YouTube. How to size your energy storage. It's already been published on YouTube on different videos. Now, I want to highlight 2 points in this slide. Things to consider. Number one, the battery doesn't only work during dark time. We know from previous YouTube videos that the solar power goes up and down. Maybe your battery, depending on your PM load, will start work at 3 p.m. or 4 p.m. Even the sun goes down at 7 p.m. So these 3 hours, you are consuming energy from your batteries. That's why you need to take it into consideration. Number one. Number two is, when I come to design my PV system, I must make sure that the energy generated of my PV solar system is capable to charge my battery plus supply the daylight load. Example, if my battery capacity that I'm gonna use every 24 hours, it's a 20 kilowatt hour, that's my battery, so I need to charge my battery with 20 kilowatt hour. During the day, my house consumes 15 kilowatt hour during the sunlight from the sun. So I need my PV solar system to be able to provide me 35 kilowatt hour as a pure output. And that's what I should take during my design consideration. That's the things I need to take into consideration. It's critical to take note of the following. The number of panels are sufficient to generate the required electric energy for the daylight use and to store the energy, as per the example that I gave you. The inverter instantaneous power is capable to support the peak load. The inverter, every inverter has a peak load. If your peak load, if during the day you have a machine or you have 2 machines that must run at the same time, and that's especially applied, this is applicable especially to the commercial. We have to make sure that my machine can give you 6 kilowatt peak power instantaneously. Otherwise, the system will fall. AC to DC and lightning protection must be well designed. Guys, especially in a large building, especially in a commercial area where there's nothing around it, you must have lightning protection for direct and indirect lightning protection. By the way, there is a video already on YouTube on my YouTube channel that discuss the lightning requirement. Indirect, it will be done by SPD, Surge Protection Device for Lightning, and so on. AC and DC protection, it's a very critical, guys, to make sure that you have a electric protection as well as mechanical protection from an AC and a DC point of view. For commercial where generator is running, that's a very important, guys. If you have a generator that must run in parallel with your photovoltaic system, it's critical to take note of the following. The generator, especially the diesel generator, should not run at no load or very low load. I need to size my generator and have sophisticated control to make sure that my generator always running at an optimum power. And this can be done by adequate solar system design, proper protection system, and communication protocol between the generator and your photovoltaic. Eliminate the injection of PV power into the generator. I know most of generator will have a motoring island mode. They have a protection for this. However, we need to avoid to make sure that the PV doesn't inject into your motor. If for any reason the load dropped and your PV now is bigger than the load, unless you have some sort of protection, this energy will go to your generator. Now, we can use a zero injection meter with CTs to avoid this CTs. Now, recommended electrical layout for residential buildings. This is a recommendation, things to consider. You must have a DC protection or an isolation. You must have another DC protection when it goes to your energy storage, and you must have an AC protection that goes to your AC load. And if you have any interference with the grid, you must have an AC protection. As a minimum, you should apply this. On top of that, you should apply lightning protection of your system. Okay, that's a very important and very critical. Now, for a commercial, we'll use the same protection from a DC point of view. The additional items that need to be introduced is your smart meter grid generator if you are injecting or if you are working in parallel with your generator set or a grid set. In a commercial, that's very critical. This will stop any current going into your machine, and also will prevent any current goes into the generator if you wanted to, or will control the power goes into the grid. Now, recommended electric layout for commercial. This is if you don't have a battery system. No battery system, you still have the same except you eliminate the batteries. Now, before we end the session, I want to discuss with you this. This is a 4 kilowatt system. As you can see, guys, the 4 kilowatt system in winter, it barely reaches 2,500, while in summer, it goes up to almost 3,500. Irrespective which one you go, the 4 kilowatt will never give you 4 kilowatt peak. However, when you want to go and discuss it with your client, you should discuss it maybe from 8 o'clock, 8:30, 9 o'clock. So your power is this power. You shouldn't tell them this is your power, because you need to tell them how many hours they can operate at a nominal power. That's why the 4 kilowatt inverter, maybe we can give it 6 kilowatt or 5 kilowatt or 5.5 kilowatt PV panels for it to give you more output during the day for operations. Now, these are, guys, the conclusions, which is you need to focus on the location of the system. Is it up the mountain, especially in Lebanon? Is it up the coast or up the mountain in the Bekaa Valley? Type and timing of the load. Do you want AM, PM load? Do you want midday load? Protection of the system, it's a very critical. If you have a presence of a generators, you have to follow a strict regulations. Advise the client of the actual generation capacity. 4 kilowatt, it doesn't give you 4 kilowatt all the day. It doesn't even give you 4 kilowatt at 1 minute. So we have to be clear and straightforward with our client. Thank you very much for listening, and we'll see you next time.